Okay, algos, does anybody have a solution they would like to share? And we're going to do the dedupe sorted first.
Yeah, we got it.
I look at your name and I'm like, I don't want to call him out. I don't want to make him do it, but thank you so much.
I try to wait long enough so you don't yell at me, but you know.
I'd put you on the payroll if I could.
Oh no, not on this one. This one was a team effort.
Okay. Yeah, I put your team on the payroll. That's
there you go.
Cool.
All right, can we see this?
Yes.
Hello?
Yeah, I can see it.
Can you see it?
Yeah.
Yeah, now I can. Okay, cool. So we started off declaring 3 variables: value placeholder, index placeholder, and splice counter. Value placeholder is for comparing to see if we have a duplicate. And then index placeholder and splice counter are for the splice function that takes 2 parameters, the index where it starts, and then how many spaces it should delete from there. We iterate through the array. And first we're just going to say, hey, if I equals 0, then that's where we're setting the value placeholder and the index placeholder to start. After that, everything else is going to come into this else statement. It's going to check and see, is num sub I equal to the placeholder? If it is, so that would mean like, okay, hey, we hit a duplicate. Then we're going to increment splice counter by 1. We're not going to console log. We're just going to increment splice counter by 1. And then at the very end, it's always going to check and say, hey, is this the end of the array? So that it knows to finish working.
Okay.
As we keep going, let's say we hit this 2, we're going to register this else statement now. So as soon as it hits a value that's not a part of one of these duplicates, it's going to go ahead and splice from index placeholder and then the amount of spaces that splice counter is up to. And then it's going to reset the index placeholder and the value placeholder to the new position and keep iterating through. And then when it hits the end of the array, it will register this, and it's just going to splice whatever it's holding to make sure that it cuts off any duplicates that are sitting there at the end.
Okay.
And if we run it. Really? It worked the last time? Okay, well, it cut off a random 3, but for the most part, it worked. Okay. It worked the last time. Right here.
Yep, I know. Okay, cool. So anybody have questions about this one?
So I know normally we try to avoid using the built-ins, but using set for this, is that slower than writing it out? As far as it running it?
So James, are you trying to do it with the challenges, like without creating a new array and all that stuff?
Yeah, this is the only one it wouldn't work on, but it should be fine for the other 3.
Okay. Yeah, so this I mean, this is like probably more advanced than okay, let me say that if we probably everybody else did something where they created an array and pushed the items that weren't duplicates into the array, right? Is that sort of like what everybody else did?
We just did result equals new set, return result.
Yeah, so you created an array and then collected the non-duplicate values, right? Or the just every value without the duplicates, right?
I mean, set kind of does that on its own, but yeah, we didn't have to.
Okay. So the advantage is basically the way James did it is if you create an array, you're using memory, right? So you're taking up space in memory whenever you declare like a variable, or especially objects like arrays or objects. So that takes up extra memory, and there's a way to do it like this without having to create additional or use additional memory. So it's more efficient, but it's probably more difficult to understand.
So that This would be
reasonable.
more efficient than set. I guess that's what I was trying to get to.
So what do you mean by set? Like what?
Let me, you mind if I steal
Yeah.
James?
Yeah, James, go ahead and stop. Thank you for sharing, James.
Of course.
I just don't know. So obviously for us, this is much easier.
Oh, wow.
Uh,
Use the spread operator.
did I?
Nice. Yeah, the three dots, that's
Yeah. So
Yeah.
for us, this is much easier, but I didn't know as far as efficiency, how much harder this is on the back end.
Okay, cool. Oh, I see what you did. Set. That's fancy. I like it.
Because it set automatically only returns
Yeah.
unique values.
Yeah, I didn't even think of that. You're right. So
Whoa.
yeah,
What am
Yeah,
I
so-
looking at here? What is this madness?
yeah, walk us through it, Robert. What does this do?
I mean, that was basically it.
We'll tell.
Wait, what does
So
that
everybody's
What was
curious.
it
Like,
called?
So set object stores unique values of any type.
Yeah.
So it was a little bit cheating, but it
it's
will
not- no,
automatically
Nah,
only
that's
take
not
unique
cheating.
values.
that's not cheating. I mean, well, so what? If I were interviewing you, first of all, I would be impressed, right, that you understood the set operator and knew that that existed. That shows more. At least you did your research, right? So what? Just so it's clear, the set. Get my notes. So this set, was it a function or? I think it's just like a operator. So a
Just an
set
operator.
in mathematics will basically, if you have a set of 1, 2, 2, 3, right, whatever, if you a set would mean that we're just only taking unique values. So converting this collection to a set would just be 1, 2, 3. Okay, so and every programming language, or most programming languages, I know Python and JavaScript have it, you can just pass a list or an array to this set function and it will automatically strip out all of the duplicate values. And so that's basically what we're implementing here. We're implementing this functionality that set does. So if you did this in an interview, they would probably say, okay, that's cool, but then they'd want you to do it without using the built-in function. Does that make sense,
Quick
Robert?
question.
Yeah.
I mean, I plan on trying this later. But is there any other way to do this without like the students like recursion, like without creating an array and stuff?
So you mean without creating a holder array?
Yeah, just kind of going off of what they said, like the old event time complexity and like, in place.
So what James showed us is the only way I know to do it. It would be you create like basically you iterate over the array and devise a way to remove the duplicates as you go through the array.
Okay.
Yeah,
Well,
that's-
like the splice, like change the.
Yeah.
It's kind of like nested loops or whatever.
Right. The splice though, that there may be some expense with that. I'm not sure how splice works under the hood, but I believe that the way James did it would be would just remove those duplicates.
How do you
Okay.
Yeah, but let me just show you.
how do you check that?
I'm sorry.
So my friend actually is graduating in May. He did computer science as his bachelor's, but
Yeah.
he said for the last few interviews he's done, that's one of the things they've asked him is to look at how efficient it is. And they've looked at how long did that take or what did that cost?
Yeah.
And they want him to be able to talk about, how efficient it was and how
Right.
long it took for it to run.
Right. Yeah. So basically, the set operator that you're using, I would imagine involves a nested array. I don't know off the top of my head, but I would imagine it involves some sort of nesting. Maybe it doesn't, but I don't know. But basically, what you're doing is like when they say big O of n, that means that for every input, the function runs one operation. So big O of n means linear time. So if there's 1,000 inputs, the function has to operate or perform 1,000 operations. Okay, so as the number of inputs increase, the number of operations increase in a linear fashion. So again, 1,000 inputs, 1,000 operations. When you have things like O of n squared, which is what we want to avoid, that's usually means there's, well, I think it always means that there's a nested for loop. So if we have an array, we're doing an operation and inside the nest, we're doing another operation for each operation. So we're taking the number of inputs times itself, right? So for every input, like if there's 1,000 inputs, there would be, what is that, 10,000 operations? So as you basically just want to look at, let me share my screen real fast so I can show you what I'm talking about here. Which one do I want to share? Okay. So do you guys see my solution to dedupe sorted? Let me stop sharing because I think I'm not sure the wrong screen. Let me do this again. I have 3 monitors, so I'm trying to figure out what you guys see. Just give me 1 second. Okay. All right, now I think I know what you see. So when I create this function to hold the values, right, this takes some amount of memory. So there's 2 types of complexity. There's space complexity, I'm sorry, time complexity and space complexity. So time complexity is what I was talking about with number of operations. So for every input, you want to count how many operations occur. Okay, so basically for every input, like meaning every time this for loop runs, what am I doing? So
You're iterating?
Yeah, so I'm iterating, but for every n, right? For every element, however many elements are in my list or my array, I'm checking equality, right? So that's an operation. So that's one operation. I don't know if, so I'm looking at the first element and then I'm looking at the next element. I don't know if that necessarily counts as an operation. We could say that it does. Let's just, for the sake of argument, let's say I'm doing 2 operations here. And then if this for loop runs, then I'm doing another operation. I'm just inserting the item into I'm pushing it into the new array. So that's one operation. So each time through, I'm doing 3 times n operations. Okay, so in math, we write that as 3n, right? 3 times n. So when we're talking about big O notation, we drop things like coefficients or something that comes in front of the number. So this would be O of, and we write it big O of n, meaning linear time. Okay, so because there are 3 operations, but it's in the grand scheme of things, like we're talking about 10,000, times 3 is 30,000, whereas 10,000 squared would be, I don't even know what it is. But when we're talking about just small little operations like this, we can drop the additional coefficient. So we can just say that this is big O of n. But if I had a nested for loop, if I had a for loop and then inside of that another for loop, I would, for every operation inside the nested for loop, I'm doing that n times n times. So however many inputs I have, if I have a nested for loop, it would be big O of n squared. Does that make sense?
Just for fun, can you throw a console.time and time end around that?
Good question. Yes. So that is, so the reason we have big O notation, right? I could do that. I could say, okay, this took, however many microseconds on my computer, right? And then you could do it. And if you have a super duper fast computer, yours may be able to do it in less time, right? So we don't use the specific machine's operating time as a gauge, because if somebody has a super duper gaming computer, it may be able to do it in the fraction of the time my 2-year-old Dell is able to do it, right?
Mhm.
So this gives us, the big O notation gives us an objective way to compare algorithms. So we can, if we just count the number of operations, and I know it's like kind of confusing at first, but this gives us an objective way to say, okay, this algorithm is better because it doesn't have this n squared. That's a good question though. Any other questions about big O? And I'm trying to, any other questions? Okay, so let me stop.